All right, so this is going to be a video about the average value of a function. And let's break this term down just so we kind of understand what's going on here. The value of a function, in this class anyway, is always going to be the y value, just like f of x is equal to y. So anytime it says average value of a function, you're finding the average y value within a certain interval of that function. The proof for this is right here. I'm going to kind of you don't really need to know this, but sometimes people want to know like where these formulas come from, so I'm just going to kind of explain it the best I can with this visual representation here. All right, so imagine you have some function, so let's try to make sense of this. Imagine you have some function f of x, so right here f of x, it's basically just this red curve right here that we're going to be looking at. There's an average y value to that, okay? So if I really wanted to, I could make a bunch of y values on this. So just if I take like this y value here, this y value, every single y value that encompasses this entire graph. And so that's a bunch of heights essentially for this graph, because it's all the y values that's going up. If I added up every single one of those heights and then divided by how many there were, that's how you find the average of anything. There's a little proof here that's a little bit better that I like to use besides just using the average. Add up a bunch of things and divide by how many things you're adding up. This one, for the average value, what I did is I created another function, it's just horizontal this time, that is the answer that we're looking for. So I just made some arbitrary horizontal line that is that average value. And while doing that, you will notice I made a rectangle here. So whatever that average value is, there is going to be a rectangle that's built off this if you go all the way down from A to B on that interval. Okay, well the rectangle here is going to be represented by this right here, the area of the rectangle, which is just base times height. You should know that from old school geometry. Well, in this case, the height, how high up it goes, is just going to be that average value of the f function right here. So this is going to be the height. The base is basically going to be the distance from A to B, which to find this distance, it's just going to be b minus a. Okay, you could just think of a number line. If you have a number line 1, 2, 3, 4, if I want to find the distance between, let's just say 1 and 4, I could just do 4 minus 1, and then I know the distance is 3. So that's why I did b minus a. It is very abstract using just b and a. We don't know what values it is. That's why I'm kind of showing you with a number line. But if you do b minus a, it gives you that bottom width, basically, of that rectangle. Okay, the base in this case. So base times height. It is important to note that this b is not the same as this b right here. It's just, I wanted to use the old geometry formulas. It's not the same b, just think of it as the base, or the width, if you want to think of it that way. Well, the base, we already kind of said that is the b minus a, that's what this is right here for the formula, and the height is this y value. In this case, I just said arbitrarily that it's going to be the average value of the function. Well, this is equal to, let's clean this up a little bit. This is equal to the area under f right here. So if you have the area of that rectangle there, whatever this area is, since it's based off the average of f, it has to be equal to the total area, including this part up here and including this part over here. Basically all this part that I'm coloring in right here. That should be equal. So that's the first premise that I had here. If you just take the average of everything, there's going to be ups and downs on that. That's kind of why there's like a negative space right here, and then there's a positive space here above that average value, y value. This is getting very complicated, but I hope it's making sense. Again, you don't actually need to know where this is coming from, where this formula comes from. I'm just showing you just in case you're curious, but I'm not going to expect it on any quiz or anything like that. All right, so that's equal to the area under f. It's equal to the area of the rectangle. The rectangle, again, is using that average y value times that width, that b minus a. Well, if you look at this right here, this formula right here, since it's equal, we're just trying to solve for this. So all we have to do is divide by b minus a, and that's where this formula comes from right here. It's just the integral from a to b of that f of x function divided by b minus a. So here it is, super formal and formal font, so you can kind of see it. You have to know this whenever you're figuring out the average value of a function. It's just the integral, and you're dividing it by that b minus a. So the integral from a to b of that function f divided by b minus a. So to solidify this, let's work out an example. All right, so we have this example right here. It says, find the average value of the function on the given interval. F of x is defined right there on the interval from -1 to 2. And I actually included the graph here just to kind of really make sure the concept makes sense. There are a bunch of y values. In this case, it's negative here. You can see a bunch of negative values here, and there's a bunch of positive y values here, all the way up. If you added up all of those heights, you would essentially be having the area. of all that. And then we're going to divide that by that b minus a. Now, if you notice, there's, the average is going to be all over the place because we have 20. This one's going all the way up to 20. This one's in the negatives. There's stuff in between. At least we have some kind of an idea of where this average is going to be, somewhere between that 20 and that negative, whatever this is down here. So let's work this out using the formula. First thing we're going to do is set up the formula. It's going to be the integral from a to b, which in this case is -1 to 2 of f of x. I'm just going to write it in there. And then we're dividing all of this by b minus a, which is 2 minus -1. From here, we're just going to simplify. We have this 2 minus -1 is just going to be 3. So that's nice and easy. This top part, I'm going to find the antiderivative. So you're going to have 3/4 x to the 4th minus 1/3 x cubed. And we're integrating this from -1 to 2. That divided by 3, I'm just going to pull it out in front and write a 1/3 just to make my life a little bit easier. Okay. From here, I'm going to distribute the 1/3 to this here, so that's just going to cancel out and be a 1. And then I'm going to distribute it right here, and that's just going to be a 1/9. And then that whole thing is canceled out because I distributed it to both of them. All right, so you're going to have 1/4 x to the 4th. If you want, you can, I'm just going to rewrite this really quick just so it's easier to see. So 1/4 x to the 4th minus 1/9 x cubed. So you have something like that. Now we have to plug in the 2, plug in the -1, and subtract. So I'm going to plug in the 2 first. You're going to have 16 divided by 4 is 4. Plug in the 2 here. You're going to have 8 over 9, so minus 8/9. That's the first part. I'm just going to use parentheses just to make it a little bit, I don't know, more organized, but you don't need that there. You're definitely going to need it on the second one, though. Plug in -1 here. We have 1, so you're just going to have 1/4. And then plug in -1 here. You're going to have -1, so it's -1, so it'll just be plus 1/9. Okay, all we have to do now is simplify this. So the 4 is going to drop down here. The -8/9 here, let me just distribute this really quick just to see it easier. -8/9 minus 1/9 is going to be just -1, and then we're going to subtract 1/4 here. So we're going to have 3 minus 1/4. Well, that's just 12/4 minus 1/4. And you end up with an answer of 11/4. And that's the final answer. Okay, problems like these are pretty straightforward. If you notice, you're just using the formula. I did not do anything tricky with U sub or making an integration by parts or anything like that. I'll probably be doing the same thing for your quiz as well, just to make things a little bit more, streamlined and exact. We already did a quiz on integration by parts and U sub and partial fractions. We don't need to worry about that so much. I'm more worried about using the formula correctly with this average value of a function. So that's average value of a function. If you have any questions about anything in this video, let me know.